Looks like we should be up momentarily. There we go. All right. It's churning away. I see nothing yet. Let's just look at that Twitch too. All right. We are live. All right. Oh, look at that! I've got my little screen up. Oh, good. I'm so excited about this. I actually get to. It's like having my own little TV station. Okay. All right. I'm going to unmute us. I'm going to go live. I am going to change to Mac OS. I'm going to get rid of that. Here we go. I'm going to get rid of that. And there we go. Fantastic. All right, little adjust. All right. Hello, interwebs. It is I, Hewlett, David Hewlett, and I am very excited to be talking today with Chris Taylor. We have had a little pre-chat, Chris. I've got so many questions because you gave me homework the last time we spoke.
I didn't mean it to be homework.
What was that?
I didn't mean for it to be homework.
No, in the best of ways. I'm going to turn you up just a tiny bit here, just in case. No way, it's the Stargate guy. Yep, it is. So, Chris, you have had what we decided was basically a pursuit of chaos throughout your career and your education, and you seem to be constantly chasing chaos. Could you let us know a little background about what you're doing, how you got started, some of the interests you've had in the past?
Sure. So lovely to be here on the podcast, David. So my background is in mathematics. I'm from the United Kingdom, and I studied mathematics at university in the 90s, and ended up going all the way through and doing a PhD at the University of Liverpool in what's known as dynamical systems theory, which at the time was heavily popularized under the term chaos theory.
Right.
And there was a lot of very good popular science around nonlinear systems and how the unpredictability is structured mathematically.
Was that that was when the James Gleick book came out? Is that the
Absolutely, yes. It was around that time, right? So that was a very good popular science book called Chaos by James Gleick. Yeah. And there was another one that was published around the same time called Does God Play Dice? Which was written by Ian Stewart, who was one of my university lecturers as an undergraduate.
Oh, wow.
And he used to drive a sports car up to the mathematics department, and all of the rest of them were coming in there on their bicycles, with one trouser leg tucked into the sock. And
it's not exactly how you picture the mathematician, really, is it?
Well, exactly.
What was the car? What was he driving?
I can't remember. It was a neat little convertible. I mean, this was 34 years ago or something. But it was a neat little convertible. I remember him, sort of rocking up to the maths department in that every day. And his lectures were good. He was, as you can imagine, he was a very good lecturer. He's very popular. He's very popular in science at the time as a popularizer.
And the God playing dice, that was Einstein's thing, where he was saying that God doesn't play dice? Was it Einstein?
That was Einstein's. So that was Einstein's comment on quantum mechanics, right?
Oh,
so
right.
Einstein had worked on his theory of relativity, and then when physics 100 years ago was moving towards quantum mechanics, then there was a randomness involved, and Einstein was almost dismissive of that, or sort of pushing back against that and saying God does not play dice, right? So then chaos theory becomes popular in the 80s and 90s, and so it was a good title for a book, because it's not the inherent randomness of the universe as in quantum mechanics, but it's an inherent unpredictability due to a sort of infinite kind of detail in the causality. So that even if you posit a universe that it obeys causal laws strictly, you still get systems which are infinitely complex.
Like that double pendulum that just...
Right.
That
yes.
You feel like it should just all line up, but of course it.
Exactly. Or weather systems or predator prey populations. you model these things, and in principle, if you know their starting position, their starting state, and you know a strict set of equations that would govern their behavior, then in principle one could predict the future. But you'd have to know with infinite precision what the starting state was, and no measurement can give you infinite precision. And in some of these systems, because they are so inherently unpredictable, they'll weave between different states in a very random looking way, even if they're not truly random in the sense of quantum mechanics. And that was the meaning of the phrase "Did God play dice?" Is, well, maybe he plays dice in a couple of different ways. Maybe he plays dice in quantum mechanics and in the causal universe as well. Whichever of those or both is true.
It's so funny because when you think of mathematics, when I think of mathematics in sort of layman's terms, it feels very specific, and very, you get you have all these wonderful looking equations, and then you have an answer. And in movies, it's always like, oh, eureka, we've got it, that's it, we're done. But your pursuit of it has brought you to a less definite, chaos seems. You're trying to sort of you're using chaos to predict chaos type thing. Is that how does it work?
Well, so when I did my PhD in the field of what's broadly known as chaos theory, but my PhD was not in applied mathematics at all. It was in pure mathematics. So it was that part of chaos theory that was
for people like me. What's the difference?
So the difference between applied and pure mathematics is that pure mathematics is just maths, right? It's just it's like algebra, for example, or pure geometry. It's saying, the theorem that the internal angles of a triangle add up to 180 degrees is a theorem in pure mathematics. It's not saying anything about the physical world or the real practical world that we all inhabit. It's saying something about the abstract world of mathematics.
So it's math for the sake of math, basically.
Right, yeah, yes. Okay. So academic mathematicians fall into two types, broadly speaking, pure mathematicians and applied mathematicians. Just going to this door here. And so pure mathematicians are of the what do we know about a triangle, or what can we prove about a triangle variety, and applied mathematicians are, well, we're going to model the world, right? So we're going to find a piece of mathematics and use it to describe the world. One of the nice things about chaos theory was that it spanned both pure and applied mathematics.
Of course.
There were models that described the weather, and you could prove that the weather could be chaotic in principle, or that the dynamics of populations of animals or whatever could be chaotic. I was on the pure side at that time when I was studying for the doctorate, and what I was studying was movements of the complex number plane, as it were. So complex numbers and functions of complex numbers, and you take a function of complex numbers and you iterate it, so you apply it multiple times, and you see what happens to the function when you apply it a very large number of times. And what that describes is a sort of abstract movement of points, and you want to describe the movement of those points in an abstract space.
But you are not working from the point standpoint. You're working from the function standpoint. So you're creating the points, or you're looking at the points and then bringing them into the functions.
So a function in pure mathematics, it always applies to a space. A space is composed of points. I'm speaking very, very generally here. Okay. So example of this. Okay. So an example of this might be the real numbers could be a space, right? So what we call the real numbers is all of the numbers that go on a line.
Right.
The middle of the line, there's no real middle. But let's say the middle of the line is 0, and everything to the right of 0 is 1, 2, 3, 4, and all the points in between, a half and a quarter and pi and the square root of 2, and all of those points. And to the left, -1, -2, -3, and minus a half, and minus pi, and minus the square root of 2.
Right.
All of those. An infinite number of points along a continuum. That could be a space. It's composed of points, an infinite number of points, and a function would be something that took that space, and for every point in the space, it would tell you another point in the space that it would go to, right? So you could say, let's take the line and flip it, right? So 1 goes to -1, -1 goes to 1. That would be a function. You could say the square of a number is a function. So 1 goes to 1, 2 goes to 4, 4 goes to 16, -1 goes to 1, minus 2 goes to 4. So this one, it takes the line, kind of folds it geometrically onto itself. And so for every function, you can think of it as where it makes points go, and you can think of it as a kind of geometrical manipulation of the space.
And that's how you visualize the math that you're doing.
Yes, that would be how I visualize it. I think mathematicians have very different ways of understanding their subject, right? So I'm a very visual mathematician.
Oh, and that's not the normal, like, not normal, but that's not the de facto way of doing it. There are some people who look at the numbers and will get meaning from that more than seeing it.
So I think it's not uncommon to be the way I am. I certainly know other mathematicians who think the same way I do. We used to say when I was a mathematics student that mathematicians fell onto, and this is pure mathematicians, fell onto a spectrum of geometric and analytic thinking. I'm very strongly on geometric thinking, but there were mathematicians who claimed not to think geometrically and to think analytically. It's so weird to me. I can't
even imagine that. Yeah,
I can't imagine it because I only imagine things in pictures anyway. I can't really imagine what was going on in their heads, But this is more delving into the philosophy of what it's like to think about things.
Yeah. Well, it's so funny because it is such an abstract. Mathematics can be so abstract that I guess
Right.
it's entirely with the inner workings of your. However, I guess there are assumptions that we make about the way we see this stuff that obviously don't apply to everybody. So,
Right.
it's fascinating. When you start in this pure mathematics.
Yes.
This leads you into the chaos side of stuff.
So the chaos. So I think the point about chaos was that it's modeling unpredictability. So the part of that I was in was very much a pure mathematics part. It was trying to demonstrate chaotic dynamics within a pure mathematical system. So the space that we were working on was the space of complex numbers, so imaginary numbers, or composite numbers, which are part real and part what they call imaginary. Which is
as we decided, the worst naming.
The worst naming. What that really means is if you think of the line that I was talking about as a geometrical object, which you can do arithmetic on, right? So you can stick numbers along it, and you can add them, you can divide them, you can multiply them, you can subtract them. You can, you take the square root of them, whatever. If you think about the two-dimensional plane, so going off in 2 dimensions, like a flat surface, the complex numbers are a way of doing the same thing with a 2-dimensional space, so that you can then do arithmetic with points on a plane on a 2-dimensional surface.
Right.
So then you can add them, subtract them, multiply them, divide them, take the square root, and what have you. You can apply a function. You can describe your function algebraically. So the chaos comes out in the following way. It's that if you apply a function, let's say you take the square of a point in the plane, you take a single point, and let's take the point 0 at the middle of the plane, and you apply your function and it goes somewhere. And then you apply a function again and it goes somewhere else. And then you apply a function again and it goes somewhere else. Now it's permissible that it could stay in the same place, but that's not very interesting. Imagine it goes somewhere else each time. Maybe it comes back to itself. Maybe it doesn't. What happens in the long run? What happens if you just keep applying the function? Can you describe the long-term behavior of what we call the orbit, this jumping sequence of points through space that you're creating? What does that? We call that the orbit of the points. What does that orbit look like? Does it look predictable? Can we describe the orbit? So say is that if it stays in the same place, well, it just stays in the same place. If it circles in towards some single point and just gets closer and closer and closer, then we say that point is an attractor point.
Right. If
it goes around and comes back to itself and then goes around again in a loop and carries on doing that forever, we say it has a periodic attractor.
Okay.
And it depends on the function, what you get. And the function, so for certain functions, they will have an attractor point. For certain functions, they'll have periodic stable orbits. For certain functions, they will produce what we call chaos.
Right.
And chaos is an orbit that never comes back to itself, never goes into a loop, never gets attracted closer and closer towards a period a periodic orbit, but just apparently describes some extraordinarily complex, infinitely detailed trajectory around space.
Wow.
And what you can show from complex dynamics, which is what I was working at, that you only need a very, very simple equation in order to produce that kind of chaotic behavior.
Huh. And see, this is where I go. This is where I can't imagine anybody just looking at the equations, because that, I mean, as soon as you start talking about orbits and spiraling in, it just all seems terribly visual to me. This is, and the chaos they were saying, this is where this three body problem thing comes in, isn't it? Isn't that where like the two bodies you can predict fine, and then the third one comes in and it basically creates a chaos of some sort?
Absolutely. Three-body problem is very interesting. A two-body problem would be a periodic orbit. You've just got a moon, let's say a planet and the moon orbiting each other. They go round and round and round, and that's a periodic orbit.
And it seems very intuitive to us, given our
And you set it up as two bodies. It's a completely describable system, and you apply Newtonian physics, right? So there are assumptions here. And if you add a third body in, then you have a three-body problem. This is a well-known field of mathematics, actually, pure mathematics, really, to try and get some handle on the dynamics of a three-body system. It's known that cannot be described entirely in clean equations, but there's still a field of mathematics in looking at it and trying to see what you can say about it.
Right. Because there's a beauty to it. I mean, from what I can see. I mean, again, I'm just watching, YouTube for dummies on this stuff. But then I guess I need almost like a definition of this chaos, because chaos isn't my idea of just complete and utter, randomness, but it is. But it's still a system that you can describe. Which I can't get my head around the idea that you can. How can you describe something if it's completely chaotic?
Well, it's not total chaos. That's the thing, right? So it's chaos with rules, and the game in studying it, I suppose, is to find out what. It's not what the rules are. You know what the rules are that have produced the system, but you can't predict the outcome very easily. You can never predict it exactly in all situations, but you can sort of say there are bounds on it, or you can prove that there are bounds on it. One of the definitions of these systems is something called sensitive dependence on initial conditions, right? So there are some criteria for what constitutes a chaotic system, and one of them is so-called sensitive dependence on initial conditions. Now that's what a mathematician would say, whereas someone writing a popular science book would say the butterfly effect, right?
Right. Oh, yeah.
Exactly that thing, right?
Not overused at all.
Not at all. No, it was a wonderful movie at one point. I really enjoyed that. So the sensitive dependence on initial conditions, well, it is a beautiful metaphor. The butterfly flaps its wings, right? Even in a system which is completely deterministic, a small difference can lead to down the line to radically different outcomes, and you can see that in even systems which have been set up in a simple way. At time, if you start from a slightly different point, you can go to a massively different end point in time.
And these minuscule differences can make huge differences later on, basically.
Right, exactly that. Yes.
Which again, that seems weirdly intuitive.
It is. I mean, I think it really is, isn't it? It was that sort of sliding doors thing, isn't it? Or there was a very nice. I remember I was a big science fiction reader when I was younger, and I used to read a lot of Isaac Asimov. I think it was Isaac Asimov, where they went back in time and they tried to think of everything. So they had this hovering magnetic walkway that took them through the prehistoric landscape, and somebody
didn't touch anything.
Yeah, but accidentally one of the scientists kills a bug, and when they go back to their own time, everything's utterly different.
And they love that. Yeah, I mean that's just being played on every level. Because it's just so much fun as well. I mean the whole concept of that. It also, I think, it also gives people a sense that they have a power. You know what I mean?
Right.
I think that's why it's appealing, because we go like, oh well, what we do it's important. It's good. It could change things.
Well, there's some very surprising results in chaotic systems. One of the things you get is there's a very simple system which is only in one dimension, and it leaps about. It's a function that leaps about on the unit line. And as you slide the parameter of the function, the orbit gets more and more. It starts out with a stable point that everything gets attracted to, and then that point splits into two, and it hops between the two, and then each of those 2 points hops into four, and the point kind of goes between the four, and then it goes eight, and then it goes it goes sort of almost to an infinite number of it bifurcates and bifurcates, and the orbit is going 2, 4, 2, 4, 8, 16, 32, whatever. But then you push it past, it's actually bifurcating at a shorter distance each time. Huh. And then there's a point where it goes chaotic, and then after it goes chaotic, it goes to 3.
Oh, weird.
I don't know why that happens. It goes to an orbit of 3. And so this is the one-dimensional version of what's called the Mandelbrot set, which is
right. This is the whole fractal thing.
Absolutely. So that's what I ended up writing my PhD thesis on, which was the geometry of the Mandelbrot set, so the fractal geometry of that.
Mm-hmm. Again, something that was in the 90s, there were like people walking around with fractal T-shirts and stuff.
Right, exactly. I used to go when I was a PhD student. I used to go clubbing, and they would project the Mandelbrot set on the on the wall of the club, and I was like, no, please,
I'm here to play, not work.
I spend all day trying to work out the geometry of that damn thing,
I could totally see that too, because it was everywhere. It was in like every music video. It was in every. I mean, of course, the dance clubs, naturally.
Yeah.
Was this in London?
Liverpool.
Liverpool, right. Sorry, I immediately think of clubbing in London for some reason. I don't know. It's not that I do a lot of clubbing myself. Talk about chaos. You don't want to see me dance. That's nothing good.
Does God play dice, or does God move in mysterious ways?
Exactly. So, I mean, what's funny about what I'm hearing here is this sounds like fun. Like it sounds like you get to play with these different sort of equations to see what kind of bizarre things you can come up with.
I think so, and I think when you start getting into it, it's a lot of fun. Certainly, if you play with it, with a computer program that produces these things, then
what do you use for that? Is that custom stuff, or is it just like MATLAB or whatever it's called?
I have to admit, when I was a student in this field, I didn't really make computer images of it. I used to certainly there was a program, and it ran on DOS or Windows 95 or whatever we were using back then, and we all had that, and we could make pictures of it and zoom into the fractals. My job as a research student was to prove theorems, and you can never prove a theorem with a computer. They can do symbolic manipulation, I suppose, but not really. You can't really prove theorems.
So you're on a blackboard or something? What do you?
Yes, absolutely.
Really?
Blackboards.
Oh, wow.
Yes. We all have blackboards. I didn't use a computer except to write up the thing, and ironically, given that I'm such a geometrical thinker, there were not many images in my thesis. It was 99 pages of inequality manipulation when I submitted it.
Dear God.
And the examiners asked me to resubmit with some extra pictures, which I hand drew.
Oh, really? Wow.
And photocopied in.
So what was the note? Like, could you liven it up a little bit with a couple of charts or something? Or what do they...
I remember going into the defense of my thesis, and this is the typical way in Britain that you defend a PhD thesis, what's called a viva exam. It's an oral exam. You have two examiners. One's someone from your own department, and one's an external from another university department. And they asked me to explain my main theorem, and I did. And they said, well, that makes a lot of sense, Maybe you should have written something like that in your thesis. And I said, yeah. I said, maybe it was a bit hard to read. And they laughed at me. And they said, yeah, you could do a little rewrite and just make it easier to read. And I was like, okay. And put some pictures in. And so I did,
That's so funny. You're getting network notes on your.
Yeah, no, that's typical way that these things go. You either, obviously, if you fail, you fail, and if there's really nothing wrong with it, then you pass. Most people, there's a few notes, and you fix a few things, and then you get through.
But that's interesting though. Again, but that also comes back to our idea of visualizing stuff, right? I mean, they needed that as well, or they felt that that was needed as well. So
They needed it, and I drew the diagram on the board, right? I had all the pictures in my head. They just hadn't ended up in the first draft of whatever draft I first submitted of the thesis, right? The initial submission. So I went back and drew them in, and it was much better.
Fantastic. Well, okay, so you get out of school, and then you went into pharmaceuticals. Was that right? Is that
right? So I went into the first job I found. So I felt
clear,
like
you didn't get into pharmaceuticals. I'm not recreational.
I mean, with the big flashing Mandelbrot sets in the Liverpool night.
It was the clubbing. I was the throwing people off. Yeah.
Exactly. Yeah. So I decided to make a move out of pure mathematics, and I found something in industry in '98 when I finished my PhD. And the first thing I found was a small family company, kind of like a startup in London, and they were in bioprocess engineering. So they were making equipment for monitoring and controlling bioreactors, which
nice.
were
cool.
Some of their customers were pharmaceutical industry. We talked a lot about fermentation. They were into fermentation,
Right.
So
I love the fermentation thing. Is fascinating to me. Absolutely fascinating. Like it just
Yeah, right. So they hired me because they had a relationship with another university in the UK called Brunel University, and there was a professor at Brunel who was a very sort of venerable control systems expert, and he had a specialty. He'd worked in industry and academia throughout his career, and he had a specialty in controlling bioreactors for fermentation.
Wow. How do they control? What were they using for that?
So fermentation, you put your yeast or your genetically modified microorganism into a vat, a reactor, and you control what oxygen is fed to it, what nutrients are fed to it, how fast you stir it. There's you can imagine this sort of tank, stainless steel cylinder.
Right.
And some of these things, we worked on controlling one that was 5 stories high.
Wow.
For a major pharmaceutical company.
Wow. It's like a distillery.
Right. Well, quite. Or a beer fermentation.
A beer, I guess,
right?
Beer would make more sense. Yeah.
So what you're doing in a fermenter is you're growing a microorganism, and then you're putting it under a particular stress. This is how you make alcohol, right? Mm-hmm. The yeast run out of whatever. I don't quite know how beer works, but they reach some point where there's too many of them, and then they go and they start to excrete too much, and it becomes yeast. Yeast excrement is basically alcohol.
Wow, way to take the charm out of that.
Yeah, enjoy your evening.
Your poop juice.
Yeah,
there you go.
Yeah. So we were working on the control systems for that, and they had funding from the government, so that they were a small company, and small companies could apply for funding from particular government programs, right. And they had funding which would allow them to work with this particular professor at Brunel University, right. And there was money to hire someone, a new graduate, and that was me.
Right.
So I went in, and that was really another world, because it involved programming computers, and it involved learning about control theory, learning a bit of biology, a bit of microbiology, and bioprocess engineering, and also it was really a kind of entrepreneurial setup. So I was out on the road trying to sell this stuff,
Wow.
with the head of
You're doing
sales.
everything at that point.
Everything, absolutely everything. It was it was like a shock to the system.
Yeah, especially coming from pure mathematics. I mean,
quite.
How'd you get the job? They're like, oh, it's perfect for this. Someone who's been thinking about math for the last.
I don't know. I mean, I just applied for the job, and I remember going for advice from the careers advisory service at Liverpool University, and the guy, he looked at it, and I said, what do you think about this job? And he looked at it, he said, that's not for PhD graduates, that's for lower level than you, right? Don't apply for that. But the other piece of advice he gave me was, he said, everyone puts as much as they can think on their resume, right? Everyone tries to fill up pages and pages. He says, you're 27, you've done not that much in your life. put it on a page. So that was good advice. I did a one-page resume and I sent it, and they thought that was bold, so they interviewed me. And then I can talk, and I had done a couple of things other than maths in my life, and I could talk about that. And I knew how to program a computer because I learned when I was a teenager. And
right. What were you programming in back then?
My father in 1982 bought a Sinclair machine, the ZX Spectrum.
Yes,
and
I've got one in England.
Wonderful, right? So
with the plastic keyboard, and the little
with the rubber keys,
yeah.
And it was the successor to the ZX81, and the great novelty was that it produced color.
Yeah,
and
that's right.
So I remember I was 12 years old. I remember counting the days until it was released. It's like we got one the week that they were released, and I was so anxious to get this thing. I had never. I remember walking to my best friend at the time when we were 11 years old, and walking into his house, and he was there with this thing, and I said, "What's that?" And he said, "That's a computer." And I was like, "What's that?"
Wow.
And I didn't know, and he was like, he had the previous model, the ZX81, which had 1K of RAM, and produced black and white blocks.
1K, people.
1K of RAM.
Yeah.
And it produced these black, and he was like pressing buttons on it. I was like, "What are you doing?" And he's like, "I'm working with this computer," and we were 11. So anyway, my dad decides to get this ZX Spectrum, and
what for? Did he have a purpose for it? Or was just purely academic?
He thought it would be good for us, to educate.
Yeah,
the kids.
My dad. Yeah, similar. Yeah. Well, only with a Commodore 64. That was his.
Commodore 64 was one of the options, right? I don't know what led him to want the Sinclair machine. It was the most popular, but Commodore 64s were really popular as well.
I loved the Commodore 64. Absolutely loved it. I wish I could get another one because it was. But that was back in the day when you didn't even have a way of, you had to input each program.
Right.
There's nothing to load it from.
Manual. I was 12 and I read the manual, cover to cover, and I took out a subscription to a magazine.
I loved the computer magazines. That's where you got all the good programs, right? You have to go type them all out. Yeah.
You type it in and you save it on the cassette player, so you get your portable radio cassette. You put the wire, into it, and then you
went away for a week and came back and it had loaded or not. Yeah.
And it made that weird buzzing sound.
Sound,
whatever it is, and soon enough, I felt like I could write my own computer programs. So my friend Paul, who lived across the road, he now works, I think, for Amazon, we sat together and pair programmed stuff when we were 12, 13, and worked out. He used to do the make like user-defined graphics. We were not doing sophisticated things, right? We were doing little games, trying to sell them to our friends.
But at the time, that stuff was quite sophisticated because people just didn't know anything about it. I mean, this was all brand new, right?
Right. Yeah. No, it was new stuff. I mean, and there were not many kids who were getting into that I knew who were getting programming, and my friend and I were. A lot of kids in my class had ZX Spectrum computers, but most of them were getting ready-made cassette games and just
It was the same with the Commodore. Yeah.
Yeah. Right.
I like the music aspect. I loved. But the programming. Yeah. I was just. I mean, I have no reason to program, but I do it all the time. I just love it.
It's so much fun. Yeah. Programming is fun,
and especially with ChatGPT now. I love doing ChatGPT because you can explain stuff to you as you go along as well. Okay, so you're programming the bioreactors, or you're programming the systems for it.
So what they used to make small scale instrumentation devices, and the project that I was brought in to work on was a computer software project, but specifically it was to do AI. Really, it was to do the project that I was put on was to build a neural network.
Oh wow!
which could be used to help monitor and or control a bioreactor which was producing a pharmaceutical product. Right?
But this was during the AI winter, wasn't it? Wasn't this during the time when everyone was like, it's never going to work?
Well, we started this project in 1998.
Okay.
So I mean, this was before AI really was doing much, right?
But just it felt like there was a drop off in there was like this this promise of it, and then it just disappeared for a while. It felt like from public view.
So I'm not sure which drop off you're talking about, right? But I mean, I think that the real, the point where it started to bite and get traction was about 10 years ago.
Right.
Neural network. I mean, I sit down and code a neural network now. It takes me 10 minutes. I get one of the standard toolkits out.
Using Python.
Yeah,
I work always. Python. Isn't it fantastic?
I work in Python. Yeah, I work in Python. Okay. Apparently named after Monty Python.
Was it really?
I think somebody told me.
I mean, that seems That seems very nerd. That seems like perfect.
It's.
I'm just going to accept that as the truth because I want.
Somebody please fact check it. But I believe someone told me it was named after Monty Python, and I now work in Python. And there's a couple of very powerful toolkits. There's PyTorch, there's Keras, or there's TensorFlow and stuff. And you can get a very complex neural network up and running very, very quickly. As in 1998, I was sitting down, I was coding in C and MATLAB, and neither of which
not quite as intuitive.
I remember making multi-layer perceptron networks in C, and sort of coding the transfer function and so forth. And eventually we did make something that a network that monitored the biomass level in a reactor. So I worked with University College London, the Advanced Centre for Biochemical Engineering. They had a pilot plant where they worked on kind of more experimental systems. I worked with some of the postdoctoral research assistants there, and they had these reactors that were making a monoclonal antibody.
I don't even know what that is.
There was some kind of, I think it was genetically modified E. coli culture in these tanks, and they would grow them up, and once they reached a certain biomass concentration, then they would hit them with, I can't remember whether it was a temperature shock or an acidic shock or something that would switch on the inserted genetic material to produce this monoclonal antibody, which was a potential therapeutic product.
So your software would be used to basically make sure that these things all happened at the right time and stuff, or that it was taking the sensor data?
One element of that. So what they wanted to do was monitor how much biomass there was inside the tank, and in order to do that, they had to take a sample, centrifuge it, whatever. So what this neural network did was it was hooked up to the constant, continuous monitoring of the gases that were coming out of the reactor, and also the stirrer, how fast the stirrer was going around, and a couple of other things. And from that continuous data, it would tell you how much biomass there was growing inside there. So you could automate that point where you make the decision to change the conditions, switch on the genetically modified bit and get the product produced.
You must love the new sensor stuff, because there's just so much amazing new sensor technology out there. I mean, just the amount of information you can get from things now at a fraction of the cost is amazing.
And the sources of data in the current world are incredible. And I remember, comparing it to 25 years ago when I was getting started. And I think really the reason why we didn't get rich kind of pushing that company was that there was never a repeatable quality source of data to work with. We got a good kind of prototype project going with the university department, but what we really wanted to do was find a repeatable product and ship it to all of the pharmaceutical companies and all of the labs everywhere. And we, every time we tried to commercialize this thing, every time we went to a customer, they say, well, we measure this, this, and this. And then the next customer, we measure that, that, and that. And it's like, well, our model's really, we're going to have to build a new model every time, right? And then eventually you just can't continue. And I got a job offer from a big pharmaceutical company, and after a few years, then you make the move on.
So when you move to the big pharma, what
Yep.
similar kind of stuff, or because what's so funny to me is that you're doing all of this mathematical modeling to start, but that is just at this point you're almost putting that aside, right? Because it becomes more of a programming thing than a mathematical thing.
Right. So it was definitely applied AI. I mean, that's kind of what it was. So there wasn't the control. There was a bit of control theory in there. Not a huge amount of chaos theory in that. I mean, what you wanted to do, control systems are there to avoid complicated dynamics. Right. They're there to make sure that if complicated dynamics start to emerge, you basically you make them into simple dynamics.
You find chaos there, you're fired. You're out of there.
Yeah, exactly. Doesn't matter what your PhD's in, right?
Right. Exactly. So pharma, similar stuff, or
it was moving from microbiology. It was moving from microorganisms to human organisms.
right?
So the target was human biology. Although we worked, the pharmaceutical companies, of course, they have animal models and cell models and so forth. But really, the aim, was to understand human biology.
Right.
Most of the work I did, and I worked for two major pharmaceutical companies, and most of the work was on cancer biology. So it was understanding the molecular biology of cancer. Right. So the signaling pathways that regulate cancer cells, all that are
complex systems.
Yeah, they're really complex.
And then the immune system gets in there as well. We just had a wonderful chat with on a as I say, the podcast that I cheat on. With a cancer immunologist, and
right.
I can't get over how complicated that system is.
It's incredibly complex. Yeah.
So you got into that stuff. There's a lot of biology here for someone who did pure math. So what are you just at home, like just looking through, the.
Well, I mean, at my desk as it was Singapore, as I moved. That job, that first big pharmaceutical job, took me to work in Singapore.
Wow!
And
I'm dying to go to Singapore. It just looks like nerd heaven.
It's great, and so I moved to Singapore in 2002, and gave up my startup bioprocess engineering job. Went to work for a big pharmaceutical company in Singapore. It was an American company, but they'd set up a new research center in Singapore, and so I was there sitting. Part of the job ended up being learning a lot of biology, and I really took to it. Cancer biology actually is fascinating,
isn't it? I mean, my father was a doctor, and I ignored what I call all the squishy science. I had no interest in any biology at all. I was all silicone-based technology, manly technology, and the squishy stuff was always just like, whatever. Now I've completely reversed. I love this. I mean, obviously I love the computer stuff as well, but yeah, the biology stuff is just, it absolutely blows me away. I love it. Those are the robots. I'm almost more interested in the human, in the organic robots now, more than the.
Well, right. I mean, I think the thing that really kind of turned me onto it, because I remember sitting there thinking, it wasn't that it wasn't that I didn't think I understood biology. It was that every time I went to read an academic paper in biology, it was like, what is this? Just words, This is just words to me. What are they? Why are they saying this and then this and then this? And eventually you work out that there's an inherent rationale to the way that biology papers are written, which is different from, say, physics or mathematics. But the thing that really got me was there's a huge book called Molecular Biology of the Cell. And
I got it. Yep. Oh my God.
You've got it. You know what?
Isn't it the best?
It's the best.
Literally, I think I've only got through like 2 chapters in about 5 years, but because I keep going back and back and going, but what a book.
It's that big grey, it's the very thick, huge tome, right?
I'm a total criminal and I have a pirated PDF.
No,
I can't do physical books, partially because if I fall asleep, I knock myself unconscious. That book is so huge that
you'd be in trouble with that one, yeah.
And also PDFs I can search. I like to be able to go bounce around. You know what I mean?
Right. No, absolutely. Yeah. No, I get that.
But I almost kind of want it on my shelf just because I'm so in love with this book.
So I was at a wedding, one of my friends, musician friend, and he was also like in finance or whatever, and his friends, as a joke, presented him with a copy of Molecular Biology of the Cell as a joke gift at his wedding, and I was there as a guest, and I was like, they came and sat back down and said, "I've got a copy of that," you know.
Yeah, and you know what? That's a generous gift because that book is freaking expensive. It's
It's expensive and it's awesome.
yeah.
Yeah,
Look,
awesome.
I would one day I will get myself an actual copy of it. But I was doing a biohacking thing with this group of like some citizen science bio folks,
Yeah,
and part of their learning process, they're like, look, you gotta read at least the first couple of chapters of this book, and so
right.
they were passing out a PDF of it. So,
So, I mean, the thing that really turned me on was a chapter on the cell cycle and how
yeah,
cells reproduce themselves. And I think this is a perfect example of a dynamical system, you know. But it's the delicate geometry of it. It's just, there's a beauty to it, and it's this. When I read that, I sort of encountered the same kind of beauty that you see in a piece of mathematics, right? That the poles splitting apart and sending out a kind of continuous gradient, chemical gradient, and two separate points. And when those chemical gradients overlap to form a kind of ring, it's astonishing that our entire bodies and the bodies of every organism on the planet are based on this kind of delicate geometry. I'm amazed that this kind of
it
emerged.
you can see why people go like there must be a god, like it's such a clockwork. I mean, the one that always gets me is the ribosome, this thing
Right.
sort of chugging along,
Yeah.
spitting out
Ribosome's incredible.
nucleotides and stuff.
And then the more you read and the more you read into it and the more you study it, the more ramifications there are of this system. And you think, well, this is clearly it's been going on for a long time. So I remember my best friend from back home, went off to study medicine. I went to study maths, and he went to study medicine. He gave me a copy of The Selfish Gene, or I gave him a copy of
Oh
The
yeah,
Selfish
yeah,
Gene.
yeah. I don't think I've read that one.
And I remember him saying, look, I've been learning more biology at university. I just can't believe that, this kind of emerged, out of natural selection. I just think we have a problem in imagining the lengths of time that this stuff's been going.
Yeah.
It's not humanly imaginable.
Well, we
So,
always shove God into the spaces, right? We always shove it into we don't know that, so that's got to be. You know what I mean? Like it's.
right, yeah, I think that that's not my idea of a decent argument for God.
Yeah, yeah, exactly. Okay, so pharmacy, you're basically trying to cure cancer, but you have an
Yes.
you had an interesting split basically where you went, okay, I'm in here, but I don't want to do this anymore because.
So I've had a reasonably long career, right? So I was in that about 8 years and working on the cancer research is fascinating stuff, and we did some really interesting work.
Right.
And and eventually, as a mathematician, you can get a little bit burned out on subjects, a little bit kind of want to think about something else. And I am that kind of person,
Right.
I enjoy something new.
Yeah, yeah,
I
likewise.
enjoy it, and I like to apply the maths, and I like to learn new domain areas. So
Yeah.
I was kind of getting to that point around the age of 40, and I'd been in kind of pharmaceuticals bioprocess about 12 years, and I found this opportunity in a totally different field.
Yeah. It's quite a jump.
Well, funnily enough, yes.
Yeah.
Yes. Quite a jump.
So
Um,
so it was gambling, right?
right, yeah.
Yeah.
So I was
I
really
don't say anything. I know you don't. Obviously, this is
sure, no,
there's a
no,
lot of
fine.
proprietary stuff, but
I mean, what happened was that I was just kind of looking for whatever else was out there, in terms of something I could apply my skills to. At this point I knew how to analyze data, and I knew how to program in various languages, and I knew some mathematical modeling and what have you. And these are
and
applicable
biology,
skills.
like
And biology and biology.
it's
lot
a
of
pretty good
biology.
package of skills there and knowledge. Yeah.
So I mean, the biology kind of went out the window. But anyway, I sort of started sending out resumes and
Your one-page
looking.
resumes.
Yeah, well, it was more than a page by this point. But I found online, I found a job advert in Hong Kong. And it was advertising for a C++ programmer, which, really, I mean, I can code in C++, but I'm not good. Um, but the name of the company was Mathematical Solutions Limited, and so I thought that's interesting. I wonder what they're working on. So I'll find their webpage, or I'll Google them, I'll find out. And actually, you couldn't find anything about this company. There was
Right.
nothing. There was literally no internet presence other than this one job advertisement. So I thought, well, I've just got to know what they do, right? It was like there was an address, so I went Google Maps, whatever. It's this street in Hong Kong. I had never been to Hong Kong. I'd lived in Asia, 6 years, but I had never been to Hong Kong. Anyway, so I sent them a CV, and then I got an email back a few weeks later from the owner of the company, and he said, oh, well, we're a horse race betting syndicate in Hong Kong.
Of course. I mean, that's what the title says it all, doesn't it?
Yeah, right. And and he said, "Oh, well, we're very successful. Can you please answer some questions?" And they were like, "No. Why are you applying for a job in Hong Kong? What kind of a person do you think you are?" Question 3 was, "Please give some likes, dislikes, etc." And no, I thought. I just got back from a job interview from a company in the oil industry, and it had gone really well. And they were definitely I felt like they were definitely going to offer me a job, kind of monitoring, making oil wells more efficient. It's really interesting stuff. So I think I just got back from that interview in Edinburgh, and I was sitting down at my computer, and I was like, what is this thing? So anyway, I wrote this email back to the guy. I said, so I previously lived in Singapore, I like Asia. And what kind of a person do I think I am? I wrote, I like to think I'm a generous person, but that could be delusion. And I just wrote this essay, and it's like, what, horse racing? I've never heard of such a thing. So I just sent this kind of essay back to him, and he loved it, right? He was this eccentric millionaire who lived in the Marriott Hotel in Hong Kong. And he'd made a fortune, he'd made $100 million betting on horses, working with a statistical modeler, and so he flew me to Hong Kong and hired me. So I thought, well, you don't get 2 offers like that in a lifetime. So certainly at the time, I mean, I'd never heard of it. I think sports betting is a bit more, so well known now.
Yeah, it's ridiculous now. But the horse racing side of stuff. So they're looking for ways to try to get a little bit of an edge on whatever information they've got.
Right. Yeah. So I mean, it's a little bit like mathematically, it's very much like let's say what an insurance company does, right? So everything is a bet for an insurer, right? So you take out an insurance policy on your car. It's like the insurer is betting that you won't crash it. Right. So they employ someone called an actuary who employs some quantitative techniques, and basically, they've got some data on you, right? They know where you live, they know how old you are, they know what sex you are, they know if you've had accidents in the last 5 years, and a few other things. And on the basis of those, they will predict a probability that you're going to crash your car in the next year, right? And they will, on the basis of that probability, they'll decide how much money you have to pay them, which is kind of a bet,
And they're mitigating that now by having like sensors in the cars as well, right? Now you can sign up for programs where they'll basically track all of your driving.
Yeah. Yeah. So you can imagine, so if you're a betting syndicate, obviously it's a very different career structure. But mathematically,
cancer?
or from being an actuary in an insurance company.
Right.
But mathematically, it's a similar problem in the sense that you've got some money and you've got a horse race and you don't know which horse is going to win, but you're going to divide your money among the horses based on a probability. So it's estimating the probability.
Interesting. So you're not just betting on a winner; you're spreading it out across the. I didn't think of that.
I mean you can hedge, as it were, your bets by betting on multiple horses. Yeah.
So basically, you're working out systems where the worst case scenario, they're at least going to lose less money than they would if they were just going. I don't know.
I mean, there are certain supposedly optimal ways to divide your capital between options, and this is there's some very good work done by the Bell laboratories in the 50s on this. There's a famous paper by a guy called Kelly, who worked. He was an information theorist working for Bell Labs, and he, in order to prove a theorem in information theory about communication channels, he used a sort of thought experiment of a horse race and said,
Oh,
"Oh, what if I?"
interesting. Oh, wow. But
So I mean, his theorem is really, is used in a lot of financial trading as well.
but my question, I guess, then comes down to this: you've just studied you've studied chaos at
Yeah,
school.
right.
Isn't the whole nature of this that tiny little differences can lead to very different? Like I just like that to me, I go like,
Yeah.
doesn't that say that it's almost impossible to do this? Then, like, the more information you get, each one of those little bits of information, it just takes one little tiny variation to make it all.
So I think you've probably got some sensitivities that you can't control within a single horse race.
Hmm.
What you would do is you'd say, you know, you've got to be in it for the long term.
Oh, so it's
You're
not just
gonna
one race.
try and win more than you lose, right?
Ah,
So
so it's like
you've got to play
Moneyball, but for horses.
exactly that,
Oh, got
exactly.
it. Okay.
And we were, in the first syndicate that I worked for back in 2011. I think we were all advised to go and watch Moneyball.
Oh, really?
Hmm.
It's great, great. I haven't read the book, but the I read his Flash Boys book about the electronic trading and how they were trying to create these networks that were as direct as possible, so they could get those
Right.
fractions of a second advantage on people.
Right,
Um,
exactly.
it's a great
So,
movie, fantastic movie. People should see it.
it's great. Yeah,
It's
for
fascinating
sure.
because it's basic, but at the same time, it's also. I thought they did such a good job of it because they also kind of show that it just takes all of the magic out of the sport. Like it goes from like these heroes and this American apple pie kind of stuff to like no, you just plod along like this.
There's more than one way to skin a cat, right?
Yeah.
I mean, it's kind of interesting to see which approach wins in a game.
And okay, so a silly question, but do you bet as well? I mean, is this something you do as well? Are you going
Not
like, hey, this
much.
is working, I should get in on this? I mean,
Sure, but if I'm working for someone else, then I'm not going to do that.
right.
Really, the clients that I've had have been playing big money, and you need deep pockets for that. And there's certain economies of scale in these things where you really can't make that kind of system work without very deep pockets. So it's much better for me to be working for a syndicate which is well funded and with a team of people, because it's a difficult thing to do to beat the market.
So instead of hunting for the gold, you're doing the pickaxes.
Right, something like that.
Yeah, that's good. And when you say big, I guess, is this a business for them or is this a passion for them? I mean,
Oh, I think a bit of both. I work for a few people. I think the couple of the guys I work for have been kind of famous gamblers, and they really have been passionate gamblers. But they've made this into something more like a business.
and you do that by just getting better information, or
Yeah. So they use data. So I mean, what's happened with the way my career has gone is that, and I've been into other things as well, but it's a few years ago people started talking about data science, and I realized that's what I'd been doing for a lot of years,
yeah,
right?
yeah, and AI for that matter. You got all the
And
buzzwords.
right,
Yeah,
yeah.
yeah.
And so now there's names for these things, and well, AI was already a term when I started, but data science really a relatively new term, and so yeah, I mean, you want to make a business based on data and information, and having better information and doing better things with it than other people. Certainly, that lends itself to lots of market games, right? So the sports betting is one, but the financial markets are very much another.
Which is just betting too, it seems to me.
Absolutely, yeah. Yeah.
No. I always say that the one AI that scares me is the financial ones, because if you teach an algorithm to just be greedy with no, with no guidelines, I just think there's so many things it can mess with to get you the money you
Well,
want.
Yeah, but I think having met some people in the financial world, I wouldn't necessarily be more scared of AI than them.
Well, no, I mean like them programming the AI is my concern. It's
Yeah,
like
right.
automating
Yeah,
their greed seems to be is sort of a nightmare scenario for me.
already happening.
Yeah,
Yeah.
I'm sure. I'm sure. Yeah. Okay, before we go into complete doom and gloom, so working in the gambling industry, but and then a complete like I would have thought like it sounded to me like a complete about face, but you shared a documentary with me that made me see the connection. But then you go into philosophy.
So, I mean, I still work as a freelance data scientist, and I work I work with various clients on quantitative work.
Like in a consulting
But
way, is that are you
yeah,
consulting? Yeah, okay,
absolutely.
right.
Yeah. In a couple of different industries, but so I'm still involved in the gambling industry, among other things. But one of the one of the things about being freelance and managing your own time is that you get to indulge your interests
Hmm.
and you get to spend time on things which are not paid work. And so a couple of years ago, I signed up for a master's degree in philosophy. Yeah.
I just love that it's philosophy. I just love that because I was like, that seems like the complete opposite to me. I'm like, from going from someone who was looking for very clear answers, you've gone to something where there are just no really clear answers in my mind.
I mean, even sometimes whether the question makes sense is a big, is a big point of contention.
Yeah, you explained it the other day. I thought it was fascinating. Whereas, like, you've gone from a place where people at least could agree on the questions to something where
Right.
people don't even agree on the questions in many cases.
Well, right. I mean, so in cancer research, we all agreed on what the questions were. So how does cancer work? How do we stop it? Horse racing, even clearer, right? Which
Yeah,
horse is going to win the
yeah.
race?
I'm losing
That's all.
money. We're doing something wrong. Yeah.
Yeah, yeah, right, exactly. But philosophy, well, what's a person? What's the difference between good and evil? And,
Yeah.
these kind of things. And even the kind of thought experiments that philosophers come up with, it's difficult to sometimes to know, or impossible to know, actually, whether these questions, no, what the answers to the questions are, whether the questions are the right questions. And they're never completely the right questions because in philosophy, quite often, what philosophers I think are doing is trying to take the intellectual tools of logical thinking and apply them to questions where there is no answer. Right? These are questions about what it means to be human, about what life is, and these are questions where. So those techniques, those intellectual techniques, they're very helpful in working out scientific problems. They've been obviously scientific progress over the centuries and millennia has been huge, and
Yeah.
human beings are exceptionally good at applying those cognitive, intellectual techniques to concrete problems, and there's conceptual work in that. But it moves forward, and you solve problems, and you make technologies, and you understand things better. In philosophy, people argue about the same stuff that the Greeks
Yeah.
were arguing about, right?
Yeah.
They're still arguing about those things. And so you think, well, is there really any well, the thing is, right, it's still a useful exercise, but not in the same way.
I was crazy skeptical, I've got to say, because I mean, back certainly when sounds like uh, when we were sort of in the school years, philosophy there wasn't a big career path to philosophy. Whereas
No.
I think now, I wouldn't say there's a huge one, but it's definitely something that's being considered more and more now as we consider things like AI and autonomous vehicles and all this kind of stuff. There are these
Right.
philosophical questions that we've been sort of pontificating for a while that now sort of come into play in some ways, which I'm
I
fascinated
guess.
by.
Yeah. Yeah, I guess.
Which brings us to you recommended this documentary, this Heidegger documentary.
Right.
Could you sort of explain that from the way you see it, what that was about? Because I found it absolutely fascinating, especially how it impacted the AI side of stuff. I thought it was
Right. So I mean
fascinating.
the so I studied Heidegger as part of this degree that I've just recently finished.
Was it a
And
focus or just a
Heidegger,
part of it?
no, just a part of it. And I,
Right.
and I have to admit, the most difficult part of it was reading Heidegger because Heidegger is almost impossible to read. Um,
Even the
and
YouTube videos trying to explain it are almost
yeah, well,
impossible to. Yeah.
yeah,
Yeah.
incredible. I mean, I did watch quite a few of them, and I read reasonable sections of Being and Time, which was Heidegger's sort of magnum opus. And Heidegger thought that there had been a fundamental mistake in philosophy. And I think what you could argue that he thought the mistake goes back to Descartes, right? Descartes, famous, I think, therefore I am.
Yeah, he was like, nope, nope.
Yeah, Heidegger's like, no. You don't even know what the I is there, right? Like you've got, so he's like, well, Descartes says, I think, therefore I am. And Heidegger goes, you've gone wrong already.
Yeah.
No, you've already gone wrong. Yeah. Because you've separated the world into an external and an internal world, and we all think we kind of all think there's this separation between the external and internal world, and then you get centuries of philosophers going, well, how do I know there's an external world? All I know is the internal world, and Heidegger's like, that's just not right. This is just a mistake based on some language problem that Descartes had, and in fact, what we all know there's a world because we're all already in a world. We're all already part of a world. But he thought that the mistake had gone so deeply into our thinking, so deeply into our culture, that we couldn't even talk about how to correct that mistake in the language that we're accustomed to. So he really tried to invent a new kind of language and did really invent a new kind of philosophical language.
And the Germans are great with words too. Germans always come up with the best words for things. Yeah.
Well, I haven't read it in German. I've read it in translation, but it's incredibly hard to read. But once you get going with it a little bit, then I think you can see, what he's reaching for there. He's reaching for a different way of describing phenomena. What he would say was phenomena. He's trying to describe experience and what it is like to be in the world, rather than say, well, I have my internal world and there's this hypothetical external world. He's saying, no, that difference is an illusion. We know that there's a world and we're in it and we're part of it. That's where we start from.
Because we're completely bound to it. Like we don't exist basically without the world that we're in, if that makes sense.
Exactly. We don't exist without the world that we're in. Right.
And I love the way, I can't remember the name of the professor or the writer who...
Oh, Hewlett Dreyfus.
Dreyfus? It was Dreyfus.
Yeah, Dreyfus, yeah.
The way Dreyfus then used that to try to educate the AI folks, like the autonomous vehicle folks, saying like, no, you don't have a vehicle that can drive around fine because it's not of this world. And I guess the thing I came away with, which I thought was just an interesting part of it, was it doesn't care. Because we care, because we are of this world, we care what happens in this world. There's just a number of these different things that came in, which it's weird because I feel like on the wrong day, I'd be like, yeah, whatever, smoke another doobie and debate what the color blue is. But there's something here because I'd only thought of the world in that, I guess I would have known it was Descartes, but this idea of separating ourselves, because you feel like that, right? You feel like you're in a little, your own little sphere. But this just kind of blew my mind because I was like, it just makes sense.
Absolutely, and it makes more sense. But I think, I think so. That idea of care, that's a very Heideggerian thought, I think.
Oh, is it? Oh, okay, all right, good.
Yeah, I think so. Yeah, I think absolutely on the right track for understanding what he was getting at, which is that things like care, things like our existence is an issue for us, right? And even when you're saying smoke another doobie, this affect of not caring doesn't make sense without caring being a thing, right? So for Heidegger, and he didn't want to use words like consciousness or self, right? He invented a new word called Dasein.
Dasein, that's it, Dasein.
Dasein.
And then eventually,
and Dasein is a German word, and its best translation is being there.
Yeah.
And he always talks about Dasein, so the being there. And he said Dasein. The thing about Dasein, it's always mine, right?
Right.
He's trying to express that. And this is a thought that other philosophers have. I mean, Nietzsche tried to express this similar thought in a different way. But there is no godlike perspective. There is no non-perspectival way. Now, science, you can posit, theories of the entire world, and in a sense, you have to, right? You're modeling what the world is, and saying, well, if the world is this kind of thing, then and obeys these kind of rules, then this will happen, and this explains what we see and what we measure. But as a being in the world, you're never going to see that overview. So, and it's a constant mistake that we always make, especially if we're scientifically minded, is to imagine that we're seeing how the world might really be from a perspective beyond all perspectives. Actually, everything's a perspective. Actually, everything is subjective first person.
Well, and imagine how different science would be if that was the basis of it, rather than this kind of detached science perspective. I mean, maybe
Right.
for good and bad, obviously. The other one that came up that I thought was, which was the biggest, is still going to be the biggest struggle for me, and probably for a lot of other people as well, was he basically is saying that until you embrace death, your own non-existence, eventually, you can't be anything other than is the only way to stop doing things for other people instead of for yourself. There's this weird, have I got that right? That we have to accept this somehow.
I think that that's certainly something that Heidegger said, and I'm not a strong enough scholar of his work to properly explain that. What I do think is that he was very concerned with, as many philosophers have been, what it is to be a self. And I think if we want to connect that to, well, is philosophy relevant? Is it useful, or is it applicable to the world? I think the idea of what it is to be a self or what it is to be a person is becoming more and more relevant as technology that we've invented moves on, because it's constantly telling us what a person is or what kind of a person we are. And politically, culturally, some of the movements that we see, are all around what it is to be a self, what it is to have an identity. These are philosophical questions, and they're being tested to destruction by the technology that we've invented.
Yeah, absolutely. And the perspective that you have going into this, especially the way Dreyfus is talking to the AI people and the autonomous vehicle people, saying like, why don't we? You need to look at it let's look at it from a different, not detached. Where the idea that you can't, there's no way to get. It doesn't matter how much information you gather around the world. It doesn't matter how many sensors you have. It doesn't matter how many things you have to try to recreate the world, unless you're recreating that connection to the world, that need to survive or that need to whatever.
The car can never care about where it's going. I think that's the thing, right?
Yeah.
And the moment where the car does care about where it's going, that's when we should be really scared.
It's fascinating because I'm a total tech optimist. I would say, to a fault, I would say. But this does make me question a lot of stuff, because you go. We were talking the other day. We were talking about one of my friends is actually in insurance and is taking a bunch of these courses right now. Wants to get into different aspects of it as an adjuster and things. And he was talking about the legalities of an accident. And I said, well, what happened? What with an autonomous vehicle? If you've got there's a fantastic video, I'll have to try to find it, of a Tesla driving down a little road. And an old man falls in front, trips and falls right in front of the Tesla. And it swerves and head-on collisions with the car coming the other way. Right. Everyone's fine, because it was fairly low speed. But it was a head-on collision. And I'm thinking, well, technically, you don't know how many people were in that car. You've got one old man who's fallen over. Wouldn't it be better to hit him than to risk a potential multi-car accident? You know what I mean?
This is what philosophers call the trolley problem.
That's the trolley problem. But we're living in the trolley problem now. That's insane.
We're living in the trolley problem.
Yeah. And who wants a car that's not going to choose you as the key? You know what I mean? I don't want the car that's altruistically going and not looking after.
Right. I mean, and if you study the trolley problem, every philosophy student has to study the trolley problem, and what does it teach you? Well, okay. Nobody agrees on what these things teach you. But what I think it teaches you is that those ethical problems don't really have a solution, right?
Mm,
That living is an art, and you can't, there's no computer program that you can encode into an automated vehicle that would be, quote, the correct thing, right?
mm,
There's always going to be a choice, and the choice always has to be made by a human being,
mm.
ultimately.
So, I mean, I suppose theoretically you could gather enough data about the person driving the car that you can make a decision based on what they would do, I suppose.
And that's very interesting,
So you
right?
could have
So
a car. So there are going to be some cars that are going to be selfish and they're only going to look after the people in it, and there are other ones that are going to be like, well, I want to make sure that So you, but again, it still wouldn't care, but you could imitate caring based on what it.
no, I think so. Now I'm imagining a court case where the thing goes to court. There's been a collision, there's been an accident, people have been hurt or killed, and the 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 person whose personality was used as the basis for the automated vehicle is sent to prison
Yeah,
because it's like
yeah. That
your car was so selfish that this is a reflection on you, so it's your fault, so you go to prison.
It's interesting though because I mean, what do you do? Like legally, what do you do? I mean, until the car companies take on all of the if you have an autonomous vehicle, they're basically taking on all of the responsibility of that vehicle. I am a huge fan of autonomous vehicles because I just think the meat puppets suck at this stuff. We're distracted, we have a bad day, we get angry, we do whatever. You know what I mean? Like,
Look, my view of it is I work in automation. That's what pays my life. I automate systems, and I am in favor of sensible automation. Everything is a design problem, right? So, but the if you helicopter up a bit, step back a bit from this design problem, what you're trying to solve is the wrong. It's the wrong thing that you're trying to solve. What we've got is a very extensive road network throughout the whole world, designed for human being drivers, right? And we're trying to make automated robot drivers to use the roads that have been designed for human drivers. No, well, you don't want that, right? What you want is test area, I don't know, Belgium, somewhere, like some large test area where you scrap all of the roads. Human beings are not allowed to drive on them, and then you work out what would be the best infrastructure. Maybe it's rails, maybe it's all like monorails. Maybe you just design it like that, and
or a
then you have
flying car, or like helicopter type
yeah,
things. Because then
yeah.
you've got different levels as well that you can deal with. To me, that seems even safer.
You go, like, and it's all, you can see how drones move. We can really go. So I think it's starting with an infrastructure that's designed for human beings and then trying to automate it with robots. It's going to come into limitations.
Well, it's the silliness of like bipedal robots as well, where we're building robots.
Right.
It's an awkward way to build a robot. They just make more sense on wheels in many cases. There's the odd situation, I guess, where it makes sense where they're having to work in a human space, but in most cases, tailor the tool to the job.
Well, exactly. Well, it's just that we've seen so many science fiction movies that we really want the
Oh
androids,
yeah,
don't
look,
we?
I mean, look, I got Meccano here. I mean, like
And
I love that idea. I mean,
Meccano. I love
yeah,
Meccano.
it is. Yeah, it's the new Meccano.
Oh, right. Okay.
It's not the little bolts like we used to have.
Oh, I
all
used to play with that stuff when I was a small child. Yeah, the
Oh,
little
I
bolts.
loved that thing. And it was a wind-up engine I had that you used to
I had
set things up.
I had an electric one with a I think it was a battery powered
Yeah,
electric
you're
thing.
younger than I am then, because I literally had a wind-up one. That's how I was pre-computers here. Look, I'm having so much fun. I realize I've gone way. We haven't asked any questions or anything. I've just been enjoying myself far too much. Do you mind if I have a look and see what Agnes got for us and we have questions?
Please?
I shall pull them up momentarily. Here we go. I'm sure she has some. Okay, here we go. So, Dom Messier, hello Dom, says, can you ask Dr. Taylor if he, as a student of chaos theory of sorts, has ever been compared to the fictitious Ian Malcolm, Jeff Goldblum of Jurassic Park fame? Kind of a weird question, but hey.
Life finds a way, right?
Yeah, exactly, yeah. You're that guy.
No,
You're the guy.
I love that, but I'm not that guy. Yeah, no, not to my face, no. But I do love the film, and I love that character.
It is a fantastic character, isn't it?
For me, he's the star of the show.
I like it, personally. I was more interested in him than well. Other than I love the concept of the DNA being brought back. But
Yeah, well,
okay.
Richard Attenborough introduces him, and he said, "Oh, I've got a mathematician." He says, "No, I'm a chaotician." Yeah.
Ah, yes. And by the way, Attenborough is also his voice is now being cloned for. Have you heard that AI stuff? They've basically
No,
taken his voice now, and as a model now, you can basically make Attenborough say whatever you want. It's bizarre.
right.
Okay, Cerulean89 says, "What's a movie or TV show that frustrated you with the misrepresentation of your expertise, and what's one that did it justice?" Good question. Wow.
Oh
Okay.
God,
I mean, good
uh,
question. Yeah, hard to answer, but yeah.
very hard to answer. Um, Well, I was watching the Three Body Problem yesterday, and there was a point where my physics is not really good enough. But I mean, there was the planets line up, and everyone starts getting sucked off the surface of a planet. I was kind of unconvinced by the physics of that.
I really struggled with that show, I've got to say. I
Mm,
I actually ended up buying the book because I felt like there must be more to it than what I'm getting here.
right.
Um, but yeah, okay, so that was a frustration. What about a good one? Any ones that you've gone like, wow, okay,
Yeah. Let me think about that and see if I can come up with one.
right.
Uh,
But you did like Jeff Goldblum in Jurassic Park, so
Yes, I thought he was excellent. I mean, he's, yeah, yeah. We ask for a scientist, you bring as a rock star. I might have got the line wrong, but it's something like that, isn't it? No,
uh,
I
it's a tough one because math is something that is generally avoided in films. It's reduced to
yeah,
a
I
bunch
think
of
yeah, A Beautiful Mind. I thought was psychologically very good
yeah.
about, what it can be like as a mathematician because you end up, the mind can go into some very strange places. I thought that was very authentic.
Hmm. What about Good Will Hunting? Did you enjoy that?
Yeah, I did.
Because you do believe that math is a not a gift is the wrong word, but is an innate ability as well. I mean, you can obviously
I
cultivate it,
think
but
was it, like everything, you can improve with training and practice. But it's certainly there's a level, an aspect of inherent ability in it. There are people who, no matter how much they train, will never be a great athlete, and there are people who, however much they train, will never be a great mathematician. Um, and there's a certain level of gift in that, and some mathematicians, there's a very long tail distribution of talent. Some mathematicians are exceptionally gifted.
yeah, it seems a bit unfair, doesn't it? There's Good Will Hunting. There was a friend of mine worked on that who is actually a mathematician, and he wrote the equations down on the board, and at one point he didn't want to do the film because he doesn't believe in innate genius. He says that it's a myth that it's and I know you're not saying that genius is innate, but his point was just that math is something of all of the things that we do, it's something that can be broken down simpler and simpler systems, so that basically anyone can get it if they have enough time and is spent enough time is spent with them to walk them through it.
I disagree.
Oh, really? Oh, interesting. Well, he also started a math. He started a math program called Jump Math. I'd love to get you guys to talk. You guys should talk. You'd love him too. He's an
So
amazing guy. Amazing guy.
I'm sure I would, and I absolutely believe that most people can be taught some mathematics. I mean, and they can be brought to an enjoyment of mathematics much more than people generally are. So, but I think what your friend is describing is a logical, a logical description of what mathematics is. Certainly, it's all, it's an intellectual construction, and you can elaborate what it is very precisely, and you can tell someone what it is very precisely. But in order to understand anything, for me, you have to have a feel for it. Kind of get back to the Heidegger thing, right? Kind of got to grasp it at a different level. So I remember when I was a mathematics student thinking, well, I can follow every step of an argument, and therefore I can see that the argument is true logically. but I never felt that I really believed it until some level I felt it. I've kind of felt it, and it was different from and maybe this is what we mean by analytic versus geometric thinking. I see the lights are
It's
going
been a
off.
dramatic lighting change. Are you being shut down? Is that it? Is that like
The co-working
last
spaces.
call? Last call. Is that? Are you okay to continue? I've got
Absolutely, yeah. No, I'm in control of the one light bulb above my head.
done. Well, it just looks more dramatic now.
Excellent.
Okay. Dom again. Dom's got another one. Was the neural network that Chris worked on recurrent, convolutional, or feed forward? And maybe you could explain those.
Okay, yeah.
Hey, Dom's showing off now. Come on.
Yeah, okay. It was a feed forward network. It was that. Now I did make a recurrent neural network to try and demonstrate a point, but it never got into production.
Is there a way to, in a nutshell, explain what the difference is, or is that?
Yeah, so a feed forward network, you start with your inputs, and then you go through a series of what are called layers. And you end up with some outputs, so one output in my case. And so the nonlinear function is it's sort of, there's a flow from end to end where it encapsulates an input-output relationship. And then so you stick some input in, you get the output out. And what we did was we trained the neural network, so you stick in the composition of the gases that are coming off the reactor, and it goes through the network layer by layer, end to end, and out comes an estimate of the biomass. Recurrent neural network would be you get to the end, and then you get your output, and then you stick it back in the back end, right? So you loop it back around. And so that there's the topology, the shape of the network becomes less simple, right? So it's not a simple topology. And what happens is that recurrent neural networks can be used to model time-dependent systems in a different way. Convolutional networks are what are currently used in widely in computer vision. What has revolutionized computer vision.
Because it's basically feeding itself back the information.
So recurrent neural networks, time-based stuff, convolutional neural networks, vision-based stuff, broadly speaking, although there are many applications now and neural networks are everywhere.
And what was the other one? The other one was recurrent?
Convolutional. So feed-forward, recurrent, convolutional were the three. Feed forward was the one I made. Recurrent is the one where you feed it back in.
Right.
And the convolutional network, that's a different kind of thing. It's the computer vision thing.
My son has just returned from his having his wisdom teeth out. He's looking good. Buddy, yeah, come in. I'm just wrapping up. Yep. All right, good. All right. So I not on purpose, but I managed to miss the process of having to take Baz to the dentist to get these things taken out. The poor kid. Yeah. So, anyways, do you ever get your wisdom teeth taken out?
No, I've managed to avoid them.
Miserable, absolutely miserable.
Not wise enough.
Okay. Dom. And Dom. By the way, I was only joking, Dom. It's a great question. This is yeah, it's fantastic. I'm just teasing you. Dom also was saying we are in fact referring to molecular biology of the cell by Bruce. Was it Bruce Alberts? Was that? It's a series of names.
It was multiple authors. I can't remember.
There's a bunch of people. It is. It's. I mean, it's almost. It's a. God, I want to say it's almost like reading a dictionary, but it's not. It's far more interesting than that. It's because it's as dense as a dictionary in a way, but it really does lay things out in a way. I'm dying to get back to it now, frankly. So, it's just it's a fantastic book. Make sure there's no more questions on that one. So, what are you doing now then? What does the future bring for you?
Carrying on with working for some clients in the betting industry, and the occasional other project. I've worked on a few one-off projects. I'm also involved in some data science work in the air freight industry. So at the moment, having studied philosophy a bit too much and failed to earn money for a while, I'm just concentrating on getting through some work.
Yeah, we are
refilling
not
the coffee.
separated from our world, and unfortunately, that means we've got to pay for it.
Yeah, yeah. Always on the lookout for interesting new projects. I recently did some consulting for an Italian company who are into sustainable tourism,
Oh
and
wow.
they've a very interesting project in the Caribbean for a Caribbean island nation, consulting to the government to try and model what the carrying capacity of it's a very small island nation in the Caribbean, and what their carrying capacity is for tourism. So what various effects are on the environment, on the economy, on crime, and so forth, and to model that based on sort of energy consumption and import export and so forth. So there's
Sustainable tourism is definitely something that's cropping up more and more. I'm hearing about it on my BBC morning news every so often now.
right. Yeah, no, I think it's going to be a real growth area. I think they're onto something. So it's been a real pleasure to kind of get in with that team, start working with their existing statistician, and try and sort of begin to bring in some machine learning techniques into that.
How do people find you? Or so if there's someone here who's like, oh, I've got a project that would be perfect. How do they get in touch with you? Is it a LinkedIn thing, or is it where do you?
Oh, this was a personal network. So someone I've known for a while, who I know from Hong Kong 10 years ago, and every now and then, we touch base, and she says, "Oh, I know these." She's doing, or I think, writing up her PhD at the moment in tourism.
Oh wow.
And she's a tour guide and very very sort of socially connected, and so every now and then she'll sort of buzz me and say, oh, I've met some people, or I know some people who want to work with a mathematician or a data scientist, and are you interested? And sometimes I say yes, and so this was one of those times.
How many? Is it something you could be doing? I guess you could do a few of these at the same time. Is that?
Yeah, it's difficult. If you've got a very all-consuming piece of work, then really you should be concentrating on that. But if there's little pieces that you can do for a couple of days, I flew down to Italy for a kick-off meeting for that project for a couple of days in September, that was a good couple of days of work, and then now I've got a longer-term client who I do most of my work for.
So you keep a pretty low profile. People find you if they need to find you, and if you need to.
Yeah, I don't need to be pitching for work
Right.
much. Right.
That's nice, nice. I'd like to get to that point. No,
It's not bad.
it's the
Yeah.
people are always like, you still have to audition. I was like, yeah, yeah, it sucks. Oh God, I have one more question for you. And I've completely forgotten what it was. Is there any? Oh, I know what I was going to say. So we love molecular biology of the cell. Is there a math or a data analytics version of that somewhere? Is there like one of those? Is there a book out there that you go, oh my God, you got to read this?
I never found it. I never found the computational biology or the mathematical biology book that really, grabbed me. I thought the work of Uri Alon was really interesting at the time. Remember that?
How do you spell that? Why is he? Why?
Urialon.
Great. Okay.
His work was really interesting.
He's got a TED Talk. Always a good sign. Yeah.
Okay.
That's what those. Always my introduction for dummies is always like it's a TED Talk or a
Yeah.
Kurzgesagt for that matter. It's the other one I love.
But yeah, I think that great work of mathematical biology is yet to be written.
And then what about just the data analytics side? Where do you find your was there a book on that or something that
A
you
lot
use?
of books.
There's a
I mean,
ton of stuff out there. I never know where to start. I did a Google Analytics course because I thought that would be a good way in, which was
for me,
great. But it's
yeah. No,
but it was aimed more at
there's a
getting a
lot of books.
job than getting into like I wanted to get more in the nuts and bolts. It was more about like how one is a data analyst, if that makes sense.
Yeah, no, I don't know any introductory texts on how to become a data analyst. I think it's something I worked my way into over a long period, and so some of the books that I like are a little more advanced. Uh,
Right. Yeah,
certainly
you're not reading the
completely.
beginner stuff anymore, I imagine. And what about sci-fi? Any good sci-fi books? You enjoying any of the sci-fi stuff? That's
Yeah, no, I wish so. I love sci-fi, and I've read a lot in my teens, and then I kind of drifted out of reading it in my 20s. But I recently, um, I joined a book club 3 years ago in London because I was back in London for a couple of years, and I joined this book club run by a philosophy graduate
oh, okay.
who's a librarian in his day job. He runs the best book club I've ever been part of
Really?
in
What
London.
sort of stuff? What's the
Yeah.
what?
Well, it's philosophical fiction. It's all fiction books, but it's philosophical fiction. So he tends to decide what he considers philosophical fiction, and usually that's pretty interesting stuff. So at the moment, I'm away in I'm in Bangkok now, but I think they're about to discuss Zen and the Art of Motorcycle
Oh
Maintenance.
my
But
God! Oh
they,
wow! I
which is
remember
one
I
of my
read that
favorite books.
years ago.
I'm kind of gutted that I'm not there for that discussion. But we do a lot of science fiction as well. Um, that's some of that's been great. So we did some Ursula Le Guin, which I
Oh
had not
yeah,
really
I used to
paid a lot
love
of
the
attention.
Dragon Riders. I didn't keep up with it,
So
but
there's a series of books. There's one called The Dispossessed,
hmm.
which is kind of about anarchism versus kind of liberal capitalist. There's a kind of moon that orbits a planet, and the society on the main planet are this kind of liberal capitalistic type society, but there's been a faction that have gone off to the moon which can barely support life, but they've got this anarchist commune society, and it's fascinating kind of thought experiment about whether such things or under what circumstances such societies can work and what would threaten
Hmm.
this utopia. In the book, there's a brilliant scientist, and
There's always a brilliant scientist.
there's a brilliant scientist,
Yeah.
and he has to go to the evil capitalist kind of dystopia in order to continue his work against his principles.
It is when you find it's. I always find it's about trying to find those books that are that balance between the science fiction without getting too into the fantasy stuff. I once it starts getting magical, it always loses me. But I love the ones that are. But you can also there's also I find there's ones that go too in depth, and you're like, all right, already with explaining how the lock works and just. But there was I remember reading one. I can't remember who wrote the book. I think it was called Steel Beach, and
Right,
it was about a like an I guess it was an AI system that was running a moon colony, and its inhabitants started killing themselves, just these random suicides, and
right,
this program was frantically trying to figure out what it was doing wrong, why these
yeah,
people who didn't need to die were dying, and it was this the whole idea basically being that that this computer code had become so complicated and was written in such an old language that no one it was basically
right.
magic again now because no one understood how to do it. So um, look, it is late for you. You've been incredible. This has been so much fun, and I want to do it again already.
Been a lot of fun.
Anything you want to touch on? Anything you want to say? Anything in particular that you wanted to
No, I
mention?
think it's been a really enjoyable conversation. Thank you so
Oh,
much for inviting me on.
so much fun, and a huge thank you to Agne, of course, for making this happen.
Okay, thank you.
Well,
Yeah.
I would say good luck with your future endeavors, but of course you don't need it because you're bypassing that as best as possible, right? So with your math.
Everyone needs a bit of luck. Yeah, we are.
Little bit of luck. Yeah. Thank you so much. Appreciate it so much. Thank you everyone for the questions. And I will. Yeah, I'll. If there's anything else that comes up, if anyone's got a great book on any of these things we're talking about, let me know because I'd love to. I'd love to know about it. And it sounds like we should be talking book clubs as well. So, thank you very much. I will say until we geek again. Be kind, be brilliant, and we'll see you soon. Cheers. I
All right,
will
then.
end our stream. Thank you, everyone. Just got to find my mouse. It's roaming around.